Good morning, students. നമ്മൾ Cauchy sequences നെ പറ്റിയാണ് ഡിസ്കസ് ചെയ്തുകൊണ്ടിരുന്നത്. So a sequence is said to be Cauchy or a Cauchy sequence if the distance between the terms of the sequence tends to 0. ഒരു സീക്വൻസിലെ ടേംസ് തമ്മിലുള്ള ഡിസ്റ്റൻസ് കുറഞ്ഞു കുറഞ്ഞു കുറഞ്ഞ് ഡിസ്റ്റൻസ് ഇല്ലാതാവാണ് as n goes to infinity, then we say that the sequence is a Cauchy sequence. So a sequence Sn is said to be Cauchy, sequence Sn is Cauchy if the distance between the terms, say Sn1 and Sn2, the distance between them, modulus of Sn1 minus Sn2, tends to 0 as n1 and n2 becomes larger and larger. Okay, so mathematically I can write this as modulus of Sn1 minus Sn2 converges to 0 means for every epsilon greater than 0 there exists a positive integer m such that the distance modulus of Sn1 minus Sn2 is less than epsilon after the mth term. Equivalently, we can say that the sequence is Cauchy if and only for every epsilon greater than 0 there exists a stage m such that modulus of Sn plus p minus Sn, nth term Sn and the terms after nth term Sn plus p for all p greater than or equal to 1, the distance between these terms is less than epsilon after the mth term. So these are the equivalent definitions of Cauchy sequence. So this is an important theorem. Every convergent sequence is Cauchy. It's very easy to prove this. Convergent ആണെങ്കിൽ Cauchy ആയിരിക്കും എന്നുള്ളത് easy ആണെന്ന് പറയാൻ കാര്യം. Suppose you have a sequence which is convergent. Suppose Sn is a sequence converging to a number L. Then by the definition of convergence we know that corresponding to every epsilon neighborhood of L we can find out a stage m such that there is an m tail of the sequence. There is an m such that the m tail of the sequence is in this epsilon neighborhood of L. So corresponding to every epsilon neighborhood of L, L minus epsilon, L plus epsilon, there exists a stage m such that from the mth term onwards, every term of the sequence is inside this epsilon neighborhood of L. So these terms are all lying inside this epsilon neighborhood of L. That means they are all inside the interval L minus epsilon, L plus epsilon after the mth term. That means ഈ ഒരു ഡിസ്റ്റൻസിനുള്ളിൽ തന്നെയാണ് ഈ പറയുന്ന mth term തുടങ്ങിയിട്ടുള്ള എല്ലാ ടേംസും. That means the distance between the terms of the sequence after the mth term തുടങ്ങിയിട്ടുള്ള terms തമ്മിലുള്ള distance at the most the distance between L minus epsilon and L plus epsilon വരുള്ളൂ. എല്ലാവരും ഇതിൻ്റെ ഇടയ്ക്കാണ്. അപ്പോൾ ഇത് തമ്മിലുള്ള ഡിസ്റ്റൻസ് ഈ ഇന്റർവെലിന്റെ ലെങ്ത് ആയിരിക്കും അവ തമ്മിലുള്ള മാക്സിമം ഡിസ്റ്റൻസ് അല്ലേ. സോ ദ ഡിസ്റ്റൻസ് ബിറ്റ്വീൻ ദ ടേംസ് ഓഫ് ദ സീക്വൻസ് ആഫ്റ്റർ ദി mth term is less than or equal to the length of the interval, which is actually here it is 2 epsilon. 2 epsilon-നേക്കാളും ചെറുതായിരിക്കും. ഓക്കെ, അപ്പോൾ നമുക്ക് എപ്സിലോൺ ഡിസ്റ്റൻസിലുള്ള മീൻസ് if we have to make the distance between the terms less than epsilon, choose a neighborhood of L of length less than epsilon, or you may take the epsilon by 2 neighborhood of L. Epsilon എടുക്കുന്നതിന് പകരം suppose I am taking the epsilon by 2 neighborhood of L. Corresponding to this neighborhood also we can find out a stage such that from the mth term onwards the terms are inside this neighborhood, so that the distance between those terms are less than the distance means length of this interval L minus epsilon by 2 L plus epsilon by 2, which is epsilon. അപ്പോൾ epsilon by 2 നൈബർഹുഡിന് കറസ്പോണ്ടിങ് ആയിട്ട് ഡെഫിനേഷൻ ഓഫ് കൺവേർജൻസ് എന്ന് കിട്ടുന്ന എം ചൂസ് ചെയ്താൽ മതി. സോ ദാറ്റ് ദ സീക്വൻസ് ഇസ് Cauchy എന്ന് കിട്ടും. ഓക്കെ, സോ ദാറ്റ് ഇസ് ദ പ്രൂഫ്. അപ്പോൾ നമ്മൾ എന്ത് ചെയ്താൽ മതി, എവറി കൺവേർജൻ സീക്വൻസ് ഇസ് Cauchy എന്ന് പ്രൂവ് ചെയ്യാനായിട്ട് വി ടേക്ക് കൺവേർജൻ സീക്വൻസ് പ്രൂഫ്. Let Xn be a convergent sequence. Let Xn be a convergent real sequence. Suppose Xn converges to some number x or L. Xn converges to L. Suppose it is convergent എന്ന് നമ്മൾ assume ചെയ്തിട്ടുണ്ട് already. We have taken a convergent sequence. Say it converges to L. Okay. So that means now to prove sequence xn is Cauchy. For that, choose an epsilon greater than 0. Let epsilon greater than 0 be given. We consider modulus of Sn minus Sn plus p minus xn plus p minus xn. I know we can write modulus of xn1 minus xn2 xn plus p minus xn. xn minus xn1 minus xn2 Cauchy's definition a sequence is said to be Cauchy if for every epsilon greater than 0 there exists a positive integer m such that modulus of Sn1 minus Sn2 is less than epsilon for all n greater than for all n and n1 and n2 greater than or equal to m. അല്ലെങ്കിൽ മറ്റേ p Sn plus p minus Sn less than epsilon for all n greater than or equal to m and for all p greater than or equal to 1. രണ്ടിലെ ഏത് വേണമെങ്കിലും യൂസ് ചെയ്യാം. Definition ഞാനിപ്പോൾ xn plus p minus xn ആണ് എടുക്കണമെങ്കിൽ we write this as xn plus p minus l plus l minus xn. By triangle inequality, we can write this as modulus of xn plus p minus l plus modulus of l minus xn, which is same as modulus of xn minus l. This is true for every n and l, for every n and p. So for p greater than or equal to 1, consider this term. Now by the convergence of sequence xn to the number l, we can write since xn converges to l corresponding to the above epsilon, say epsilon എടുത്താൽ നമുക്ക് ഇവിടെ 2 epsilon കിട്ടുള്ളൂ എന്നറിയാം. അപ്പോൾ corresponding to epsilon by 2 there exists a positive integer m such that modulus of xn minus l is less than epsilon after the mth term. So that I can write mth term ശേഷമുള്ള എല്ലാ ടേംസും l ന്റെ epsilon നൈബർഹുഡിലാണ്. So p greater than or equal to 1 ആയതുകൊണ്ട് n greater than or equal to m ആവുമ്പോൾ n plus p is clearly bigger than n. So for all n greater than or equal to m, we have n plus p also greater than or equal to m because n plus p is bigger than n and n is bigger than or equal to m. So this inequality, say 1, implies xn plus p is also in the epsilon neighborhood of L. Oh, നമ്മൾ എടുത്തത് epsilon by 2 neighborhood ആണ് അല്ലേ? Epsilon by 2 ആണ് കൺസിഡർ ചെയ്തിട്ടാണ് m എടുത്തത്. Okay. So it is in epsilon by 2 neighborhood of L for all n greater than or equal to m and p greater than or equal to 1. So take this as condition 2. Then from condition 1 and 2 substituted in inequality star, substituting 1 and 2 in condition star, we have modulus of xn plus p minus xn. എന്താണ് condition star? xn plus p minus xn is xn plus p minus xn is less than or equal to modulus of xn plus p minus l plus modulus of xn minus l, and we have from condition number 1 this is less than epsilon by 2 and the other thing is also less than epsilon by 2 for all n greater than or equal to m and for all p greater than or equal to 1. That means this is less than epsilon. Okay, that means sequence xn is a Cauchy sequence. So every convergent sequence is Cauchy. Okay, every convergent real sequence is Cauchy. Now ഇത് വേണമെങ്കിൽ മറ്റു ഡെഫിനേഷൻ യൂസ് ചെയ്തിട്ടും ചെയ്യാം. എങ്ങനെ xn converges to L എന്ന് assume ചെയ്യാം. അപ്പോൾ for every epsilon greater than 0 there exists a positive integer m എന്നോ അല്ലെങ്കിൽ k എന്ന് എടുക്കാം, such that modulus of xn minus L is less than epsilon. Epsilon എടുക്കുന്നതിന് വരെ epsilon by 2 എടുക്കാനായിരിക്കും നല്ലത്. Epsilon by 2 for all n greater than or equal to k. അപ്പോൾ നമുക്ക് പ്രൂവ് ചെയ്യേണ്ടത് modulus of xn minus xm less than epsilon എന്നാണ്. അപ്പോൾ കൺസിഡർ ചെയ്യുക modulus of xn minus xm, and we can write this as xn minus L plus L minus xm. By triangle inequality, this is less than or equal to xn minus L modulus and modulus of L minus xm, which is same as xm minus L modulus ആയതുകൊണ്ട് സെയിം തന്നെയാണ്. And for all n greater than or equal to k, this is less than epsilon by 2. This is less than epsilon by 2 for all n greater than or equal to k. And this is also less than epsilon by 2 for all n for all m greater than or equal to k. If m is greater than or equal to k, the second term is also less than epsilon by 2. Then we will get epsilon. Okay, so we have for every epsilon greater than 0, there exists a positive integer k such that the distance between the terms of the sequence is less than epsilon for after the kth term. So that means sequence xn is Cauchy. ഇങ്ങനെ നമുക്ക് പ്രൂവ് ചെയ്യാം. By assuming the sequence is convergent, we can prove that the sequence is Cauchy. This is an alternate proof.